Welcome to the 2020 AZ Water Virtual Conference. Thank you for attending. Also, a big thanks to our conference sponsors. My name is Melissa Dar, and I will be moderating this presentation. In this video presentation, April Zhang will present Greywater filtration design for single households. April is a rising senior attending Basis Oro Valley. With the guidance of Professor Everbach from Swarthmore College's Engineering Department and the Pioneer Academics Program, she has gained experience testing water sample quality and designing small-scale water filtration systems. And with that, I'll turn things over to April.
Thank you, Melissa. Okay. So water scarcity has always been a prominent issue in arid regions such as Arizona. And recently, there have also been growing concerns regarding the Colorado River drying up. So this has a direct effect on the water levels of Arizona's Lake Mead and Lake Powell, which have reached historically low reservoir levels. And then in addition to this summer, we have been continuing to experience some of the highest temperatures. So excessive heat warnings have become a very common weather report. And one solution to this problem of water scarcity is greywater. So greywater is water without fecal contamination that is recycled for purposes like irrigation and toilet flushing. So basically water from your kitchen or from your laundry machine. So when greywater is reused either on site or nearby, it has the potential to reduce the demand for a new water supply and also reduce the energy and carbon footprints of existing water services, and then meet a wide range of social and economic needs as well. So the reuse of greywater can really help to reduce the demand for more costly, high-quality potable water. Next slide. So here, figure 1 illustrates the volume of water in acre-feet that Oro Valley receives from reclaimed water, groundwater, and CAP water. So CAP stands for the Central Arizona Project, which is basically referring to the canal that connects the Colorado River to central and southern Arizona. So if you look on the graph, you can see the amount of reclaimed water, which is shown in purple. It has been increasing dramatically since about 2005 to 2006. So this indicates that communities have become much more accepting towards the reuse of greywater. And then another thing to note is that if CAP water declines, so if the water coming from the Colorado River does decline, this could be made up by reclaimed water. And then this will also address the problem of demand for water going up as production increases, because we are having a population increase in Arizona. So this filtration system could save around 110 million gallons of water annually, and this is approximately 337.5 acre-feet. So on the graph, it would look like this. So if you click forwards, this small red square rectangle in the 2018 bar in the very bottom right, that would represent the 337.5 acre-feet. So in reality, this is only a small dent in water production because the filtration system only considers single households and not things like private industry or businesses, etc. Next slide. So to target these concerns and to present alternative options of water reuse within individual households, I have designed a cost-effective greywater filtration system for local Tucson households. And of course, this filtration system is not restricted to just the Tucson area. The design can be modified for households in any region. But it's a good thing to note that this design does utilize the greywater filtration design base that is recommended by the City of Tucson. So essentially, the system will divert used water from laundry machines for the purpose of toilet flushing. And this is really useful because we don't always require the highest quality potable water for something like toilet flushing. And then if implemented on a mass scale, this greywater filtration system would not only provide an efficient method to help conserve water, but also offer homeowners a path to lower water bills. Next slide. Okay, so before we jump into the design, I want to go over the quality of the greywater. So I sampled 5.7 liters of used laundry water from a top-loading washing machine, and then left that in a plastic bin for 24 hours undisturbed. And then after that time, I found there was a thin layer of foam and detergent on the surface of the water. And then I'll address this later in the design. And then I also conducted a dissolved oxygen test on the Greywater samples from the washing machine using the Hatch dissolved oxygen test kit. And there's a picture shown on the right here. So dissolved oxygen is a really good proxy for pollution, especially organic pollution. So if you have a higher dissolved oxygen value, it indicates that there's less bacteria in the water because there's less food for the bacteria to eat, so they're not using up that oxygen as quickly. So after I conducted the dissolved oxygen test, I got a value of 5 milligrams per liter, and this is relatively unpolluted compared to normal wastewater, which usually has dissolved oxygen values under 2 milligrams per liter. So this indicates that the used water does not require a very intensive filtration system. Next slide. So design overview. So this filtration design has 3 main components. You have the settling tank, the skimmer, and the sump pump. So if you click forwards once. Yeah, so the settling tank will be the main storage container for the laundry water. So after the water has been diverted from the laundry machine, it will go to the settling tank. And at the bottom of the tank, there will be a tray, and there's going to be small rubber fibers that protrude upwards. And these rubber fibers will help the debris settle and cling to the tray better. And then I'll go over each of these parts in more depth later in the presentation. If you click forward once more again. Yeah, so the floating skimmer will run across the water in the settling tank, and it's going to remove the top 1 centimeter of grease and detergent that was observed before. So an important thing to note here is that the floating skimmer, so it's going to move back and forth across the water, and it's floating, so it's resting on top of the water surface. So for example, if the water level is rising, if it's higher or lower, the floating skimmer will be able to follow the changing water level. And then click forwards once more. The sump pump will use a pressure-sensitive mechanism to pump water to both downstairs and upstairs toilets if need be. And then again, this design may vary from household to household, considering the volume of water used for laundry and toilet flushing. And then additionally, the sludge or the debris that's collected at the bottom of the settling tank can be reused as plant fertilizer. Next slide. So at the start of the Greywater treatment system, the Greywater will be diverted from the laundry machine. So it has to be diverted from a pipe that usually goes to sewer to a pipe that goes to the filtration system. So laundry machines typically have 3 tubes that protrude from the back of the machine. So 2 of them are bringing water to the machine, both hot and cold water, and the last pipe carries away the wastewater to the sewers. So here, at the junction where the wastewater would usually enter the sewers, there would be a 3-way valve. So this 3-way valve will basically divert the water to the settling tank. And then a 3-way valve is useful because it also allows the toilets to be supplied by either regular potable water or treated gray water. So in this design, there will be 2 3-way valves. One will be at the junction where the wastewater will be diverted to the settling tank. And the second 3-way valve will be near the toilet, where the homeowner can choose between flushing the toilets with the treated gray water or the potable regular water. So this valve also acts as a safety net for any problems that will occur within the gray water filtration system. So for example, if there's a problem with the system, the homeowner will still be able to switch that valve and choose to flush their toilets with regular potable water instead of the treated gray water. And then this design will utilize PVC pipe. It's ideal for this design system because it greatly reduces material costs. And then furthermore, the water being drawn through these pipes will not be consumed, so the PVC pipes really pose no health hazards. So this Greywater design system ideally is best constructed during the development of new houses. So this is primarily due to the increased level of ease for piping, so using sturdy PVC pipes in this case. But if you would like to install this design in existing structures, so existing homes, you can use flexible piping. So for example, cross-linked polyethanol, otherwise known as PEX tubing, PEX. So holes can be drilled into the walls, and then the PEX tubing can be fed through to the desired locations if you would like to install this design in an existing house. Okay, next slide. So in the first part of the filtration system, the water will undergo a process called settling. So this is basically where the large debris and particles are able to sink to the bottom of the tank, leaving the majority of the water clear of any major debris. So I estimated that a 100-gallon plastic water tank will suffice for a single household. But the capacity of the settling tank may need to be modified according to the amount of water used for laundry and toilet flushing for that specific household. And then if there's a chance that the water tank does not meet the carrying capacity required, you can install an emergency pipe to the side of the tank that will transport all overflow water back to the sewers if need be. And then again, attached to the bottom of the settling tank is a plastic tray with rubber fibers that protrude upwards that will help the debris cling and settle better to the tray and remain undisturbed. And then this tray should be sized according to the width and length of the water tank. Next slide. Okay, so another thing to note that there will also probably be an excess of grease and foam from the laundry detergent that remains on the surface of the water, like I observed when I sampled these 5.7 liters of Greywater initially. So to remove this top layer of debris, we have designed a skimmer. So a skimmer is basically a piece of metal that is suspended above the water surface, and it's supported by any two kind of flotation devices, so foam or anything like that. And this will allow the skimmer to hover over the water surface and then scrape away the top 1 centimeter of debris. So this device will move back and forth about 2 to 3 times, and then any debris that is scraped off is deposited into a tray at one end of the tank. And then this side tray will also be supported by any 2 types of flotation devices. So this tray requires obviously regular maintenance to dispose of the debris. And then the skimmer will be powered by a motor connected to the sump pump's motor. So for instance, when the sump pump is activated, it will initially activate the skimmer. So after the sump pump is activated, the skimmer will first skim the top of the surface of the water, and then the sump pump will begin to pump the water to the toilets. So skimming the water surface when the water is undisturbed allows for maximum efficiency to get rid of all of that grease and foam on the top. And then there will be a 10 to 15 second delay between the initial activation of the sump pump and the water filling the toilets, and this is ideal. So when the sump pump is activated, the skimmer turns on afterwards, and this is similar to a chain reaction. And then for this, a relay can be utilized. So a relay is basically a device. It's a switch that controls one electrical circuit by closing or opening contact with another. Next slide. Okay, so the final component of the design is the sump pump. So the sump pump functions super similar to a regular water pump, but the distinguishing characteristic of the sump pump is its pressure-sensitive mechanism. So basically, to explain this in more depth, when the toilets are full, the pressure in the pipes will build up, which will signal the sump pump to stop pumping water into the toilets. And then vice versa, when the toilet has just been flushed, the pressure in the pipes will lower past a specific pressure. And then this will signal the sump pump to begin pumping water into the toilets. So the sump pump will use the toilet's built-in mechanism when providing water. So when the water drains into the toilet bowl, the inlet valve will open and close based on the pressure exerted by the float ball. So thus, the integral system of the toilet is not modified. And then going into the numbers a little bit, so the main characteristics of the pump would be a maximum output pressure of 3.5 psi, and then this was found just by calculating the density of water, by the gravitational acceleration constant, and then the maximum height of the upstairs toilet. So once the output pressure falls below the specific 3.5 psi, the switch activates the motor pumping water into the toilets. Next slide. Okay, so this is just a more comprehensive diagram so you guys can better understand all these words that I'm throwing at you. So here, once the water exits the laundry machine, it will encounter the three-way valve where homeowners can choose to send that laundry machine water to the sewers or to your system. So once it is diverted to the Greywater filtration system, it will enter the settling tank And then the larger debris will settle to the bottom of the tank. And you can see there's some rubber fibers protruding from the bottom of the tray. And then this tray will be very easy to clean, to remove. It will have handles, although these are not depicted in the diagram. And then the skimmer, you can see, is the gray rectangle floating on the surface of the water. So that's going to move back and forth across the water, getting rid of all that grease and detergent that has built up there. And then that debris will collect in the side tray. And then the sump pump, you can see, is submerged in the settling tank. So this design is super condensed design, so it won't take up a lot of space. Next slide. Okay. So in a super brief cost analysis, the material cost for this Greywater filtration system is anywhere between $300 to $600, excluding labor costs. But this system will be relatively simple to self-install. So currently the dollar price for water in the Tucson area is anywhere between $2 and $6 for every 1,000 gallons. So because of this, there have been no super strong motivations to install Greywater systems. But now the city of Tucson has begun to provide a 25% tax credit for the cost of installing a Greywater system. Next slide. Okay. So in conclusion, this design utilizes the recommended City of Tucson Greywater filtration design as a base, and then incorporates new innovative elements in the design, such as the addition of the sump pump, the floating skimmer, and the relay. So although this design is designed for single households, it can be further modified to serve larger buildings, such as schools or libraries, businesses, things like that. So this Greywater filtration system is implemented on a mass scale in the larger Tucson area, allows for a super drastic reduction in the required potable water intake, so up to 110 million gallons of water, like I mentioned earlier. And this will help to address water conservation concerns in arid regions and throughout the world as a result of climate change. And with that, I'll turn it back over to our moderator, Melissa, if you have any questions.
Thanks, April. I do have a few questions. How do you plan on commercializing your filtration design?
Okay, so this is a really good question. So I plan on working with my local Tucson construction companies in the development of new houses to help popularize my filtration design and then begin installation in homes under development or homes undergoing remodeling. Another option would be to propose this design to the city of Tucson or local governments as a recommended design for a Greywater filtration base, and this will also help to commercialize my filtration design.
Awesome. What are the advantages of your filtration system compared with other ones that are already on the market?
So this filtration design is super simple. It has only 3 main components, and it's easy to self-install in existing homes as well. And the material costs will only go up to about $600, whereas many more complex filtration systems on the market have much higher material costs and require labor fees, making the system anywhere from $800 to even $4,000 to install. And then another advantage of the system is the fact that the filtration design is condensed. So it won't take up that much space, whether you keep it in your garage or you keep it close to your laundry room.
Great. Well, thank you, April. That was very interesting. And thank you, ladies and gentlemen, for attending. That concludes our presentation, and we will see you on the next video.